Hi, hello, good evening. Welcome to the PDSA. This is the first session. Uh, Today we are here to introduce the PDSA course and as well as the week 1 summary. Both the things are included in the today's session. Hopefully, while I'm going that each of the part, maybe sometime you got any clarification. At that time, please raise your hand so that I can get back to you who are being raised the hand instead of you are continuously doing a conversation. So that doesn't help us. So that if you want to have any clarification, just you quickly raise your hand so that I can get you with your name only, right? Correct. So I think Divya, you want to ask something? Actually, hello.
Hello.
Divya, tell me, sir.
No, sir, actually your voice is little bit lagging.
Is it?
Can you
Hello.
please come close to the mic?
Yeah, I'm here close to the mic only. So is it happening to everyone?
No, sir, it's
Yes,
perfect.
it's fine, sir.
No, sir, it's clear.
Because I have that external mic, which is completely different from complete
Eh,
setup.
Yeah, we are able to hear you very clearly. I think there's no issue from
Okay.
your side.
Please, Divya, could you check that your network delay or something like that? Okay. Yeah, great. So actually, first we walk through the course introduction and how really the grading and what is the complexity of the course, how to get good grades in this course, and as well as that how this course will help you in kind of future trends and current trends. That's all the things we cover initially, and then immediately we jump to that week 1 summary. So that's regularly we do that, particularly each week. But this week is we start with the introduction of this PDSA. So mostly as per your seniors introduction or seniors review or maybe some of your peer review, PDSA course, everyone says that it's hardest course or hard course where we cannot clear with good grades, right? Is it common feedback you got? Generally, maybe some of your peers or some of your, yeah, that generally
Yes,
it
sir.
happens because the content is very huge. We can say that more syllabus, more content, more concepts, more problems you need to solve it. That's all put together so that PDSA course is somewhat huge. That is definitely everyone has to accept it, including the instructors. But it is a good course. Why do you say it's a good course? Is basically it's a strong course required for any programming background student who are doing programming they want to do, and it's a lifelong learning. The PDSA course, it's not done only for this particular century or past century or future 10 years of decade. No, not like that. It's a long time and lifelong learning. We can assume that. So why do you say it's a long, lifelong learning is PDSA course, it starts with the basic programming where you already learned with Python. Maybe that programming syntax is only we use it. But we write that efficient implementation, efficient algorithms. So how this PDSA will help you for your career is any particular recruitment or any kind of placement, if you go for it, or internship, basically they try to conduct one technical test. Maybe it is mostly on programming things only. In that programming they'll give that algorithms oriented concepts of that only, right? Because you need to implement in any language, mostly Python is preferred, and in that they try to solve that particular problem within a given period of time and efficient solution they want to identify. Maybe 15 people have submitted correct solution, but out of 15 people who have been done that efficient way, like the execution time of the algorithm is a constraint which is strictly verified, and based on it only you will be selected based on to the next level. That happens. So this is the actual kind of thing. But when you come to the PDSA course, basically you can see that your SIG dashboard, this is your grading, because I want to share that your SIG dashboard only. So please see that, whether are you able to see my screen?
No, sir, you're not sharing your screen.
Just I'm sharing. I think now it's okay. Is it okay? Hello.
Yes, sir.
Yes, sir.
Yes.
See, look at that. This is the grading policy, how the PDS is. The grading policy, it includes that, so kind of other general courses, most of the diploma level courses, they have the quiz 1 and quiz 2. The quiz 1 date is October 26th and quiz 2 date is the November 23rd, and end term is that December 21st. So what is the portion for this syllabus for this one is, quiz 1 is up to that week 1 to week 4 syllabus. Whatever the contents are there, week 1 to week 4, that content is there for the quiz 1. But in the quiz 2, there is a content from week 1 to week 8, but more focus on that week 5 to week 8. Maybe out of 16 or 17 questions, I'm not sure, but definitely 16, 17 questions you'll get it. 2 questions might come from that week 1 to 4. There is no restriction. Just definitely 1 or 2, because earlier pattern of QPs, the behavior analysis of the QPs, if you see that, the pattern of QPs, week 1 to 4, you might have 1 or 2 questions in the quiz 2. Rest of the questions, like 14 or 15 questions, are from week 5 to week 8. That is the quiz 2. And regarding that end term, you have that week 1 to week 11, but there is a content week 10 that is not included. Even it is not included in your end term, quiz 1 and quiz 2. That is an additional content. Actually, the string pattern matching is used, but that is not given in any quiz, any end term examination. This is the complete portion of quiz 1, quiz 2 and end term. And whenever you think about, say, I'm coming back, don't worry about it, any clarification, very soon I'll come back. And there is a OPP examination is there, like, online proctoring examination, that is scheduled on 7th December. So that is, OPP, you can say that only one OPP. If you are absent for OPP, then repeat OPP will not be provided in the next term. It does not impact for the passing of the course, only it impacts to the grading of your, that particular, if you pass that OPP examination, if you attend for the OPP examination, that is helpful for improve your grade, but it is not considered as a pass grade. So that if you register for OPP, if you do a OPP, what is the advantage also, I'll talk now, don't worry about it. Now, there are graded programming assignments are there. What are the graded programming assignments? Every week you have. So A2, A3, up to A8 is there. So average GRPA scores in week 2. Actually, graded programming assignment in every week is not only 1. You might have GRPS 2, GRPS 3 based on the week length. So average of second week, third week, fourth week, second week to 8th week is taken. So based on it, who is eligible for OPP is the student has to complete the OPP. There is a system compatibility test is there. Before OPP examination, your system configuration has to be tested. There is a documentation for it, SAT system compatibility test. And whatever this particular GRPAs are there, graded programming assignments, each graded programming assignment should be 40 and above, like, each average every week. So like A2 to A8. So if you miss that one of the particular GRPA, you are not eligible for OPP. Make sure that. So this is very important note, which everyone should know that. Because last time also somebody said, sir, I missed A3, I missed A4, please give. No, there is a policy has been done. So that policy, we cannot change it. So be careful. So every weekly you should do that graded programming assignment timely. And then you have to reach that 40% and above. So combined of all these is being considered to eligible for OPP. So OPP is a programming, programming examination which contains that 4 problems are there. That 4 problems you need to solve it in 2 hours. So this is the OPP. Why really? Because somebody might feel OPP examination, it will helpful for only that increasing the total grades. It is not required for end examination. Why to struggle it? But definitely you require. If you are a PDSA certified student, every company when they are recruiting, they try to conduct a technical test. Am I right or wrong? This technical test contains that there is a algorithm or problem you need to implement. This implementation you need to do that efficient way. So efficient means time complexity has to be very less. How can you do that? If you regularly practice GRPS, practice programming assignments, and weekly live coding sessions are there. So actually every Wednesday there is an open session is there where we'll talk about that summary of the week, and every Friday we have a live coding session is there. That thing also you need to practice. These are different problems.
So one question.
Mm.
In live coding session, what you going to discuss?
Live coding session is a different set of problems which are almost similar to your GRPA.
Oh, GRP and PPA.
PPA is a different kind of PPA, it is not graded one, no, right? Mostly the complexity level and toughness is equal to GRPA. And sometimes it is more than GRPA also. Clear? So, and as well, this is a regularly you need to practice GRPAs, PPAs, and weekly live coding sessions where instructor will take care about it. And there is a TA sessions are there. I think if you could see that there are 2 TA sessions are there, right? Hello.
I don't think they are scheduled on the calendar right now.
Maybe they'll schedule very soon. Don't worry about it.
Okay.
This TA session, one TA session is about PYQs, the previous year questions, because you can pick out some questions, otherwise the particular TA can pick out some particular questions and he will discuss. Another TA session is there, second TA session is there. This is exclusively some competitive programming, problems like lead code or hacker rank problems he will discuss. These 2 sessions also very much important because PYQ is mostly it is related to your quiz 1, quiz 2 and end term, because all those are objective and numerical type, right? So whenever you come to the second TA session, it is also linked to your OPP examination. Once OPP, all the things you have been practiced well, you can easily crack this technical test. Any internship if you go, so basically first they will test it whether it is algorithms you are able to implement in an efficient way or not. Once that is cracked, then you go to the next level where the interview they might check it your projects, your communication, all these are. But basically you supposed to crack that, the coding test which has been conducted by the company. That's very important for any kind of entry level of your, I think, any of your position. So this the thing why we strongly recommend the students don't think that OPP is not having the eligibility to end it for end examination. Make sure that you should go with OPP. Is it clear? Anything about OPP doubts?
Sir, not about OPV, but there are 2 things that I want to clarify.
Okay, I'll
First,
come to it. I'll come to it. Just let me complete that OPP is okay. Is it clear,
sure,
everybody?
sure.
Anybody?
In the instructor live session you mentioned, right? Like, will
Hmm.
those problems be uploaded in dashboard with test cases like GRPAs, or how will that be shared?
That is live coding session problems are available in the your Seek portal only. In your Seek portal on the same Friday, if it is coding session is there, every Friday we'll have a live coding. There is a problems are activated. Clear? So if 5 problems are there or 4 problems are there, instructor will solve with discussion of you. Maybe 3 problems he'll solve it. 1 problem he will leave it. Clear? How to solve it and how to code it, right?
Okay, so that starts from week 2, is it? Because for week 1, I'm not able to see those problems.
Maybe from the week 2, I think. No. It will be released on the Friday morning, it seems, right?
Oh, okay.
Because every Friday we have a coding session, live coding. So on
Okay.
the day itself, we'll release, right?
Yeah, okay, thanks.
Okay, yeah. Okay.
So
Is
one
it?
question. So one question on the OPP point of view. If I go back to Python programming course, they used to give this practice, previous year's practice enablement, so that we could do a lot of practice with those sessions for the OPP sessions alone itself. So do you have a plan, similar plan, like you can
Correct.
open up a OPP similar past session so that we can practice?
Correct. OPP mock also there.
Okay, thank you.
Okay, fine. Yeah. So this is about OPP. I think everybody is clear. Okay. Regarding OPP, everything is clear. I think now some of you have been trying to ask that other doubts.
Sir, one thing.
Sir, I wanted to check when you said there's particular week which is not included.
10th
Can you
week
please
actually. 10th
week
week.
10? Okay, sir. Thank you.
That is released, but there is no evaluation part. There is no quiz part. There is no nothing else, right?
Okay, sir. And also, sir, Friday session are going to be conducted on the same timing as
Yes,
of
8 to
Wednesday.
10. Same.
Okay, sir. Thank you.
So Wednesday and Friday are instructor sessions. These are same 8 to 10 only. Okay. Yeah. I think. I think.
Sir, one more thing. That you told us that some TAs will come and take session based on they will practice PYQ. So week-wise PYQ they will practice.
No, not week wise actually. Generally, what he will do is he will get it from the previous year questions. In that, he will segregate generally. This question, when he is discussing, he say that, okay, this question is from this particular term, this is from the week 1 concept, definitely. Okay.
Yeah.
Sir, one question about SCT, sir.
For some lead code
Hello.
problems.
Wait. Please raise up your hand because I am unable to identify who is speaking, please.
So I am speaking right now. Sir,
Yeah, Dibay, please talk about.
Sir, for lead code and hackathon problem, will TAs come and filter the problems from lead code platform?
Correct.
And they will give DSA problem based on which will be best to solve by Python.
Correct.
Means
You can solve it with Python only.
So there is some code I have observed in lead code. The run times may differ based on the language. Are you using C++ or Python?
No. Only Python only because they will selectively they'll come with Python problems only. They'll consider only Python problems because it's a PDSA course. Okay. Yeah. Piyush Raj.
Yeah, sir. My question is about SCT. Sir, now I'm staying at MP and I'll upload that photo of here only. But I'll not available on. I'll be somewhere else on 7th of December. So it will be fine, sir.
I think what is the due time given for SCT? How many days before SCT must be finished? Actually, I'm not aware about it. Before what time OPP? What time you need to finish up SCT?
No,
Sir,
sir.
but
Any rule?
So actually, we have already done our system compatibility test in foundation level, and we are continuing the same system. Should we do it again?
No. That location also is there taken, no, right? You must allow the GPS location also, right? So that it is to be done before that OPP. So you do one thing. Just see you can just a minute. There is a course lead is there, Mr. Abdul Pratap Singh. You can ping it because I'm not sure before how many days you need to finish it, right?
Oh, yes. Atul Pratap sir.
Yeah. He is a course lead who can clarify before how many days actually. He is the first course lead. He is the first person. Okay. You can ping him how many days before that SCT has to be finished, right? If we change the location again, there could be a problem, definitely. But how many days there is a grace time is there, right?
Actually, sir, my question is also a follow-up question. Basically, sir, I have done my SAT during a SC course back around two to three terms back. So, sir, how do I know like I am still eligible for my SAT is perfectly working or not? Like
Again, I think you can check it, right? There is SAT documentation was given.
Okay.
You can check one more thing because not right, near time at OPP, just tomorrow, day after tomorrow, you check it whether compatibility test is passed or not, right?
Okay,
fine.
sir.
Wait. Suman, you want to ask
Sir,
something? Wait. Please let me finish up that who has raised hand. Suman.
Sir, I wanted to know what is the approach to finish the course throughout.
Definitely.
Okay, sir. Okay.
Definitely, I'll just simple walkthrough. I'll give it. Okay. Yeah.
Okay.
Trilok.
Yes, sir. What installation, Python installation, we need to have on our laptop because right now for all the Python programming questions, I'm using the standard whatever interface the portal is giving.
Correct.
Seek portal is giving. But is there other requirement which has to be programmed outside? If I want to try out something, which one is what the course instructors are advising?
No. Just it is VS Code is enough for with
VS
Python
Code
compiler. That's Python compiler. That's enough. PDSA
Okay.
course required. That's nothing else.
Thank you, sir.
Okay.
Sir, can we use Google Colab?
You can use Google Colab, no problem.
Okay, I'm not having that much. Oh, sorry, please continue.
Sir, I have searched in Google, searching the videos how to install the library function in Visual Studio Code, but I'm not satisfied with that. And can you please suggest us some easier way to implement the library function of Python in the Visual Studio?
No. The library functions, you can just directly do pip installation, right? If you do a pip installation, simply it will install any package. Yeah.
Pip installation, how to do that?
Yeah, this is very simple. Maybe any library, just let me start that. Maybe I'm going for my Python compiler. This is my Python is already installed. I'm going for VS Code. Maybe CD, my Python folder is there. Okay. So where I do that code dot, immediately my VS Code is open. So in this VS Code, I can install any particular package required for it, going for terminal, new terminal. In this terminal, if I want to install, maybe I want to install any, I'm sorry, just terminal is open. If I want to install a Flask package, pip install, maybe I want to install Flask, any package, Flask I want to install. This is installed, right? If I want to install Jinja template, pip install Jinja, simply it is installed. Anything, actually it was already installed, that's what it is, installation is updated. Any package you want to install, you can do the pip installation. Nothing else required, okay?
Oh, just pip install that.
That's it. Okay. Yeah. Purnendu. Sorry.
Yes, sir. So I have two doubts. First one is regarding SCT. So I did my SCT for SC last term only. So I have to give the SCT again?
Yeah, I think we need to give it. Just to check with Atul Pratap Singh, maybe, because if it is same location, same mission, I think we don't need it. But anyway, cross check with him, okay?
Okay.
Even you can post it in the discourse also, right? Before it, even you can tag my name. Actually, even I'll inquire about SCT only, because how many days before, after the session, I'll ping him. I'll let me know that immediately. I'll respond in the discourse. You can post Atul and me. Similarly, we will reply on that. Okay.
And second question is regarding the course content. So I have gone through all the lectures and everything, and I was solving the GRPA and PPA today. So the course content and the questions which are asked are totally different. So means like how to cover it, because in the course content they are basically teaching means like the week 1 content is mostly about all the things from the Python, means like a recap from Python and some time complexity and how to write algorithms and all those, right? But in question, they are using sliding window and all those advanced things. Means not advanced, but yes, at a beginner level, we haven't covered all those things. So means like what to refer and how to go about it.
Correct. So there is a live coding session is there, which is actually every Friday it is scheduled, right?
Okay.
So on that, mostly when that particular GRPA you have any doubt, there is a clues we'll give it on Friday sessions. Don't worry about it. Clear?
Okay, so we will be doing that.
Correct. Because so that while live coding session problems which we are solving is so much it is equal to GRPS only, very near to GRPS.
Okay.
And sometimes they are tougher than GRPA. If you are solving the live coding problems, you can easily figure out whatever GRPA. It's not a big deal, right?
And OPP, sir?
OPP also. That's what I said about walkthrough. OPP is linked to PPA. PPA after that GRPA. GRPAs you can solve if and only you are attending for live coding sessions. And then immediately you can attempt that OPP. Once you, it is a simple kind of links, all these are, right?
Okay. Understood, sir.
Yeah, Bishwas.
Yes, sir. Actually, I have a question about the passing criteria of OPP. Is there any minimum marks criteria, sir?
Yeah, it's there, I think. Just a minute, please go through it. Okay. See, look at here. This is grading policy. Eligibility, we got it? Got it. Okay. So, yeah. So, this is eligibility for it. Attending for end examination, where you should get the best average of 7 weekly assignments. See, weekly assignment includes that graded assignment, GRPS, graded programming is there, graded quiz is there. So all these two, every week you have GRPA, we have graded assignment. These two, best 5 is taken out of 7 weekly assignments where the score should be 40% above. So attending at least 2 quizzes in the center. So we have only 2 quizzes only. So that if you want to attend for end term examination, you should have that weekly assignment out of 7, 5 average is taken, and as well as you must attend quiz 1 and quiz 2 both. This is the criteria to attend for end term examination.
Okay,
and
sir.
Then we go for it. See, the OPP examination, actually, there is no passing score. Actually, generally what happens is there are 4 problems are given in OPP.
Okay.
So in this, first problem is definitely easy. Maybe I'm not sure how many marks is, but definitely it is going to be 20 marks, something like that. Clear? Similar way, you have the second and third problems are there. Definitely these are moderate problems. So these are maybe combined together. Let's assume it is 50 marks. Each one is 25. And fourth problem is definitely tough problem. This is almost 30 marks. All these put together will help you to increase your final score. See, you can hear this is the score in the online proctoring remote examination. Why they are not included passing criteria for OPP examination is either you pass or not, it doesn't make help in the eligibility for end term. It will help you for increasing the score, right?
Yes, sir. Yes.
If you are absent for OPP examination, you will lose the weightage of this 0.2 P. You will lose it, right?
Yes.
This will you lose it. That means almost 20 marks you lose it, right?
Yes.
So if you attend at least 2 problems, you solve it. 1 problem you solve it. Something you get it, right?
Okay. Yes.
That's what I strongly recommend.
Okay, sir.
Yeah.
Thank you, sir.
Yeah, I think this is clear. GAA, quiz 1, quiz 2, OPP, and F score, all these are.
Yes. Oh, yes. All of this are clear.
Now, somebody asked that how to follow these courses. It's pretty simple. See, you get here. Let's assume that we are going for a learning policy, not only getting good grades. Along with good grades, we want to make this course is a lifelong learning. So basically, everything is live streamed. So we strongly recommend you must attend for Wednesday session and Friday session. Wednesday session, you will understand the concepts. And Friday session, you will understand that, coding problems, like, live coding. These are. If you are unable to attend, because most of you have been working professionals or you might have other assignments, if you are not able to attend it, I kindly recommend you watch these in your immediate holiday, like, maybe watch on Sunday or on, Sunday or Saturday. Something definitely will help you. And you can do fast forward also, because once you easily do that would help you then. These two are compulsory, because entire all PPT slides, all the particular week content we are delivering in 2 or 3 hours in the instructor session means that will help you a lot, instead of going maybe all the videos. If you are going that professor lectures, all the videos is well and good. If you are not able to go, this is the basic thing which you definitely require. If you are not able to watch them immediately or join in the immediate live session, I recommend you kindly watch on Sunday or holiday, immediate holiday. Please don't neglect it. And the next one is in the TA sessions, as and when you get the time, please attend for TA session also. Because TA session PYQs are there, that is definitely help you to get the good grades in the quizzes, because previous year questions are there, quizzes. And along with it, there is important sessions are there. Mock 1 for quiz 1, mock 2 is there for quiz 2, and end term also there is a mock is there. These are handled by the instructors. Here also we will discuss PYQs. Clear? Hello? Hello?
Yes, sir.
Yes, sir. You're audible.
Maybe
you're
maybe 11th hour, maybe you missed it, some PYQ sessions by TA. You are unable to figure out that quiz, but quiz is scheduled day after tomorrow or maybe coming week, or what should I do? So mock sessions we are conducting. First 4 weeks we have a mock, 5 to 8 weeks we have a mock, 9th week and 11th week you have one mock. So in this 9th week and 11th week mock, we'll discuss all the questions related to that week 1 to week 11 also, because some questions we'll bring it from week 1, some questions we'll bring it from all these put together. And in this previous year questions also we'll pick up, maybe almost 30 questions, maybe mock 1, mock 2, end term, if you combine together, there are some standard pattern of questions are there, we'll discuss in the instructor session only. In that time, there is no particular week content delivered in that week, either on Friday or Wednesday. Before the quiz 1 and quiz 2 and enter, we'll have a mock session. And your self-learning, if you want to do, there is a GitHub notes is provided for you. This is very comprehensive notes where everybody can access it. Just I'm pasting in the chat box. Kindly acknowledge that. Are you able to access or not? Are you able to access this?
Yes, sir.
Yes, sir.
This is complete content is there. Quick walkthrough. You can do a quick walkthrough, quick understanding, immediate implementations, immediate time complexities. Mostly we use this particular GitHub notes only to deliver our open sessions. Clear? Okay.
Yes, sir.
These are sequence of things you need to follow. So this is what GitHub documentation. These particular things will help you to get the good grades, and as well as it will help you that a lifelong learning policy. So you want to become strong in the programming, definitely there is a lifelong is required. Clear?
The problem I have observed, most of the student face, I also face. We can solve the problem given the PYQ, GS, but when it's time to write code by yourself, it's becoming a very hectic job.
No. PYQ does not contain coding problems. It contains quiz problems, right?
Yeah. And
These problems are only the objective type, whether it is MCQ, MSQ or NET. Clear?
And sir, how to make a good thought process while logic building? Because
Yeah, logic build is simple actually. Just actually, it's a maybe everyone have their own policy of building their logic. So generally, what I say that if any problem statement is defined, maybe just you consider one example, maybe sum of two numbers, just sum of two numbers. So as and when you say that sum of two numbers means, oh, everybody says that, oh, it's an easy problem. Okay, why do? Everybody can understand it. But some people will analyze this problem statement. You said sum of two numbers. Is it real numbers or integer numbers? That's what we'll ask it. This is the first question we'll ask. And they said it is real numbers. Okay, fine, that's good. So you said it is real number integer, you said it is the real number sum you wanted. You want me to write as a function or as a simple program? So this is the second question we'll ask to understand the problem. They said it is you should return a value. Okay, good, very good. So now, so this function, is it takes parameters? Is it takes parameters or arguments? See, why I'm talking about this is, once a problem statement is there, don't directly jump to the code. You ask more and more questions until you understand. Either you might ask your friend, your senior, or Google, whatever it is. But understanding the problem is the more important. Once you understand the problem, then you figure out the approach of solving. So maybe someone says that approach of solving, anyway we are using ChatGPT, OpenAI, that you can use it. But thing is, if you use that any kind of LLMs, nobody can avoid it because everybody is using. Who will stop you? You can use it. But once you use LLM, you get an answer, and then try to understand the answer. Really, that particular answer is right or wrong. So whether you are able to figure out better than that one, that you have to figure out. Just appreciate that ChatGPT and don't come out. Please try to figure out that better problem can be solved.
I also go through when I'm just last time I finished my Python. I also get through such kind of things while solving the problems and taking the help from LLM. But I think if you take lots of help from LLM, then your thought process will not be developed that much. And most of the time you will start in the problem thinking what to do, what should I do, how to start the problem, and such a thing that at a point of time you will be exhausted and I have done with that and I'm not able to do the problem. Even I can't think how to go through the problem and how to write the code and what to do here. Use the for loop, use the if condition, or while loop.
So if that problem you started, you try for something easier problem than that. So which is similar problem, and definitely some easier problem is there. You are unable to solve the problem which is that A, maybe it's a tougher problem. You try that at least A before, like some of easier problem than A. So then if you solve it, definitely you'll get. Maybe at the time you are exhausted. If same problem you try day after tomorrow or after 2 days, definitely you can solve it. No doubt about it. Only thing is you need to figure out that logic, and that logic you need to digest it, and that logic you need to digest. If you digest it, you never forget it. That's the thing. Repeatedly, if you figure out the particular same problem, definitely there is no chance of forgetting the solution. There is no shortcut methods where I say that it's all traditional approaches only, because somebody says that AI will overcome it overcome where it will overcome that particular the coding implementation, it will overcome. But better optimized solution, again you need to figure out, okay, A is given solution, whether it is optimized solution or better solution, you need to figure out it. You need to certify it, whether it is the right solution or not, right? Okay. Mohit.
Yes, sir. I just wanted to ask, like, where the recordings will be available.
Yeah, there is a channel is there, PDSA channel, where you can go there. There you can find this term, right? This term. There is a PDSA channel is there.
Okay.
Okay. Okay. Yeah. Purendu Shukla.
Yes, sir. Sir, one thing that I find it hard is that so means like coding I am able to do, questions I am able to do, but the mathematical part of the course, right? The time complexity and the number of iterations it will take, the number of recursions it will go. So these type of mathematical concepts means these are not mathematical, mostly programmatical, but I find it little hard to.
No, it's pretty easy. Anyway, we'll walk through that. This week is not complexities much, but we'll initiate the complexity. Second week is exclusively time complexities. Okay, there you will definitely you'll get a clarity. First, this week itself you get a clarity. Whatever summary I'll talk now, and when you enter into the second week, you get a clear-cut idea of that. What really is time complexity? Whether you are able to understand it or not, right? Don't worry. Yeah. No, you don't need great mathematics. Basic mathematics is more enough. Yeah. Mukesh Kumar.
Yes, sir. My doubt is I will not professor lecture attend. So I will only attend a live lecture. So live lecture, all topic cover or not.
Yeah, all topics are covered. Every week there is a live session is there.
Okay, sir.
Okay, every week. Every Wednesday we have a live week session. Okay? Yeah.
And sir, my Python course, some topic a week, object, programming. So I will course understanding.
No, definitely strong programming skills are required. This course definitely requires strong programming skills, but you can get it by practice only.
Okay, sir.
It's not so easy like Python, and similar way, it is not very tough. If you don't practice it, definitely it's tough. Regular practice is important. Yeah. Mukesh.
Okay, sir. Thanks.
Balram Murugan. Balamurugan, sorry. I'm sorry.
Yeah. Sir, my question is, you just told about the sessions taken by the teacher assistants and summary sessions. I'm just scheduling the dates. I actually took 3 courses. Wednesday there is a summary session. Friday there is a coding practice. You said on a Tuesday there is a TA session. Am I right, sir?
Correct.
The timing is same, the 8 to 10.
No, actually, I'm not sure. The TA calendar, let me check it. Actually, I'm not sure. Yes, let me check it. Calendar which I got.
Sir, where to find all the sessions?
No, actually, you can check your SIG dashboard whether. Actually, that TA session, even I did not get any updates. MAD TA sessions, I got it. But I did, MAD, I got it. But I did not get any TA session for PDSA.
Open summary session is there in my calendar.
Yeah, maybe they will update very soon, right? Okay.
Okay.
Even so weekly 2 session is there, Wednesday and Friday.
Wednesday, Friday are instructor sessions.
Instructor. Okay. And TA session, there is a 1 TA session or 2 TA sessions?
2 TA sessions, 2.
Okay. One is on Tuesday, another one is, sir?
I think Thursday, I think so.
Okay. Thank you, sir.
Yeah. Okay. I think it's pretty much that the grading policy, the course walkthrough. Now, can we go for week 1 content?
Sure, sir. We can go.
Yes, sir.
Wait, just give me 1 second. Say, look at here. If you could open your GitHub summary, that will show you the complete context of your PDSA course, where it will be available in the supplementary content very soon. Actually, the supplementary content itself, they will provide in your Seek dashboard. There is a supplementary content. Actually, they are not added. We will ask them to add it in the Seek dashboard. So this particular link, you can use it meanwhile in the same particular summary. So this is the basic index of it. See, as I said, it contains totally course of the 12 weeks. Of course, it is 12 weeks means the string pattern, it is not available. This is extra content only. This will not be available anywhere. It is not there in NTerm or anywhere. So regarding for quiz 1, you have week 1, week 2, week 3, week 4. So up to here is that quiz 1, and 5, 6, 7, 8. This is exclusively quiz 2, but some part of 1 or 2 quiz questions you can expect from week 1 to 4 also. And this is exclusively NTerm, like dynamic programming, and actually they're supposed to say that 10 and 11. Unfortunately, they said it is 11 and 12. Sorry. These two are NTerm. NTerm means these two are additionally added and combined of all. Like NTerm, it contains almost double of quiz questions. Maybe we can expect 28 to 30 questions, 30 plus sometime. 30 questions you can expect from all the weeks. And what I strongly, my particular observation is, I strongly observed it, quiz 1 is very easy. Very easy. I can say that it's a very easy. Why it is easy, you know? This part of 1 to 3, up to this 1 to 3, all these are linear data structures. These are linear. Why it is this is week 1 to 3 is linear data structures. So again, I'm telling you what is linear data structure. Linear data structure is very simple. Sequentially, we will process the data one after another. So that what called, you know, it's a week 1 to 3. Mostly it is a linear data structure. It is very easy. Week 4 is non-linear data structure, but initial part of non-linear data structure is very easy because basically it started with graph traversal algorithms. That's it. Yes, so that no problem. But from week 5 to remaining part is very complex, heavyweight. Content is used, number of algorithms you must familiar is very large. So you can say that, actually we can say that week 5 to rest of up to 11, these are somewhat hard weeks. So that quiz 2, it is very much a difficult portion is there. And NTerm also you can find that, you know, difficulty in the second part of weeks, like week 5 to week 11. That portion contains that number of algorithms are increased. So that's what, you know, I want to make you to alert, like how would you prepare for it. First quiz is very easy, so that quiz 2 is tough. Then it comes to the NTerm. Still it's going to be tougher than that quiz 1 and quiz 2. So I think you understood, right? Okay, yeah. So now let me go for that week 1. So I think you are able to see that particular GitHub documentation. So if anybody have that Python issues or Python syntaxes you want to know, just you click on this where it opens Python documentation. This documentation will help you for quick reference because somebody wants to access GitHub nodes of Python, they can access this. Maybe some have a doubt. Yeah. Now, I want to tell you that, so I'm going for my rough work. See, whenever we write any PDSA implementation, we write user defined functions, right? Is it right? Any function we write, mostly user defined functions only, we write programs. User defined function means it will do a specific task. The function is defined a set of instructions. That set of instructions will perform a particular task. Now, the function, what it contains, set of instructions. Set of instructions. So we need to measure how many instructions are there. We can say that if it is case of algorithms, how many steps are there in the particular function. So that is considered, see, the number of operations or instruction when the program will run. Let's assume this is your function. There is a total function is there. How many instructions are there inside the total? 2, right?
Yes, sir.
Yes. So this is the first instruction, this is the second instruction. Now the thing is, if you could see that this particular function, how much time you required for this instruction is 1 unit of time. So don't think that 1 unit of time means 1 second or 1 microsecond, 1 millisecond. Consider it is a 1 unit of time. It's a constant. That's it. Similar way, return statement also 1 unit of time, because one time it is executed, right? Right? Yeah.
Yes, sir.
Yes, sir.
So here, this particular function, whenever you talk about this function, highest asymptotic complexity, if you can consider, this particular function is maximum 1 time only. Maximum is 1 time. 1 unit of time. Don't worry about big O and all. We'll talk about big O and all second week. Don't worry about it. Now, we are coming to the second part of code. This is another part of code. This is one instruction. This is one instruction. It is 1 unit of time. 1 unit of time. Now, is it iteration or loop? Am I right?
Yes, sir.
Is it iteration? Can anybody say that?
No.
This is a loop, right?
Yes, sir. It's a loop.
How many times this loop is executed?
Until you get the n.
N times. N times.
N minus 1 times.
0 to n minus 1.
0 to n minus 1.
So frankly, we can say that 0 to n minus 1 time, because incrementing every time from 0 up to n is not included, so that n minus 1 time. Of course, you can say that it's n times. Inside what you have written also, this is also n times, right? Is it right?
Yes, sir.
Yes, sir.
This is again 1 time. Now, this entire function, asymptotic time complexity, if you talk about that, this n plus, 1 plus 1, and then another 1 time is there, again n, because each instruction, 1, 1, and this is n times, this is n times, this is n plus 1, n plus n, and one more is, this is 1. See, this entire one is a function of this particular function. Maybe, I don't know, maybe this could be f of x. Let's consider some random function. Now, this is entire function. Is it right? This entire function or not? Is it right?
What you did here?
Yes, sir.
No. Total, how many instructions are there? Each instruction, how many number of units it is taking? Time units. Clear? Unit of time. Hello?
Okay, sir.
Yes,
but,
sir.
but why the print statement is not in time, sir?
No, just a minute, I'll come back. Wait. Okay. Now, inside of this particular polynomial expression, highest asymptotic time complexity is considered by ignoring constants. We ignore constants. Constants we ignore. Clear? In this particular terms, what is the highest? N is highest, right? Hello?
Yes, sir.
So that's the reason this, hello. For example, if you write that 2n square plus 3n plus 2, this is my function, right? Hello? For example.
Yes, sir.
Now, ignore the constants. This constant you can ignore. This constant you can ignore. This constant you can ignore. So now what is the highest time, highest asymptotic time complexity?
N square.
N square.
So that this is n square. Similar way, this function 1, 1, 1 plus 1, n again plus n, then it is 1. In this, constants are ignored. What is the highest asymptotic notation here?
N.
So that this particular function also n times. Is it clear? Is it clear?
Yes, sir.
Now we are coming to next function. I'm going for next function. Is it okay?
So sir, it's time for big O n.
No, forget about big O. It's n times. Clear? Big O, omega, and then theta we'll talk about in the second week, right?
Okay, sir.
That is a different issue. Right now, this function is taking how many number of units of time, right? Clear? Hello? Yeah, hello?
Yes, sir.
Yes.
I'm going for next function. Yeah. See, look at here. Now another total function is there here. Now again, another total function, it contains various instructions. This is 1 unit of time. So this is n times. Is it right? Hello?
Yes, sir.
Yes.
Now, this is not n times because it is inner loop. This is outermost loop. This is inner loop, right?
Yes, sir.
Yes,
For
Now,
each iteration, it will run n time.
Now, this inner loop is executed outer loop number of times. Whenever this I is 1, j is repeated 1 to n times. Whenever I is 2, j is repeated 1 to n times. So that what happens, this particular j loop is repeated again n times of outer. So definitely it's going to be n square. Is it right?
Yes, sir.
Yes, sir.
Yes, sir.
Similar way, this s plus 1 also n square because that's also nested inside. And of course, this is 1 time.
1 unit.
Sir, once could you repeat n square part, sir?
Right. So whenever I value is 1, I is 1, j is repeated 1 to n. Of course, 1 to n means 0 to n minus 1, right? Is it right?
Yes, sir.
Similar way, whenever I is 2, I is 2, j is again repeated 1 to n, right?
Yes, sir.
So that totally this inner loop is repeated n square times, right?
Okay, yes, sir, I understood.
So that
we can also write I times n, sir.
Correct. No, I times you do not say because I first time it is 1, j is 1 to n. So if that is a different issue because right now I is outer loop, j is inner loop, j is not linked to I. J is just repeating 1 to n times, right?
But j is repeating every time.
Not I times, n times. Clear? So that is a different loop. For example, if you write like this for I in range.
Yes, sir. I comma n. Range.
Correct. That's a different issue. Okay. Yeah. So now,
Sir, suppose I have written for I in range of n for the outer loop and for inner loop j in range of I comma n.
Correct. So again for j in range of I comma n.
Can you share the book with us?
So at this time, what happens? This particular one. So first time j is repeated 1 to n times. Clear? Fine.
Yes, sir.
So what happens that this particular 1 to n times means definitely it's going to be n minus 1.
Yes, sir.
Yes, sir.
Next time it's going to be n minus 2. Clear? Because I is increased means j is decreased, right?
Yes, sir.
So again, n minus 3. So again, if you do that asymptotic, it is equal to n square only, right?
Yes, sir.
Almost it is near to n square. Clear?
Yes,
Hello?
sir.
So that
Yes, sir. It will be say n into n minus 1, I think.
Correct. N into n minus 1, correct. So, and then finally, this entire function highest asymptotic time complexity is n square, right? Highest term is considered. Because out of these all instructions, these instructions are taking more unit of time. So that more unit of time only considered. Is it clear?
Yes, sir.
Yes, sir.
For example, 3 nested loops are there, which includes that 1 to n, 1 to n, 1 to n. Then what is that highest asymptotic time complexity?
N cube.
Correct. Exactly, it's n cube. So you remember up to n cube only. Don't worry about beyond it. So anyway, we'll discuss more things in the week 2, big O notation.
Sir, can I ask one thing?
Mm-hmm.
Sir, you are using asymptotic nature. What exactly is?
That's what I'm talking about. Asymptotic means right now highest term of time complexity.
Okay.
If in a function there are multiple 1 unit of time instructions are there, 2 unit of time instructions are there, n unit of time instructions are there, highest term is considered. In a polynomial expression, different terms are there, highest term is considered. Clear?
Yes, sir. Yes, sir.
Sir, for n cube, there should be another loop inside J, so that
Correct.
okay, yeah,
I
yes.
loop is out in outer, J loop is inner, another K loop you might take it. Fine?
Yes, sir. Yes, sir. I got it.
So this is that basically how you understand your user-defined function. If you write a user-defined function, it is doing the job means don't consider it is the best coding pattern. So you need to check it. How many number of units of time it is consuming. There is other parts of things it impacts to your algorithm. Maybe your hardware, because maybe your algorithm is efficient, but your hardware is a weak memory, weak processing is there. As a software engineer, we don't worry about hardware. Hardware is our not issue. Our objective is, as a software developer, our objective is always implement optimized algorithms, optimized algos. That is our course PDSA will give you the guidelines. Always we try to build best algorithms. So we focus on always the best time complexity or best time involved efficient algorithms. So we try to investigate whatever the code you have implemented, whether it is efficient or not. So that's a reason when you know, if you go for any MNC, you know, any kind of maybe recruitment process, 3 students has been developed same problem solution, but out of 3, 1 of them only selected. The reason is maybe he has used his best time complexity algorithm, best approach to solve it. The function you write a total function, total function, total function. 3 students has implemented total function, but 1 of them is efficient, so he has been cracked and has been selected by the company. So this is what we try to focus. I think up to this is clear, right?
Sir, in the real scenario, we do the complete timing, right? For the performance of the algorithm, you have to go for including all the instructions, not just the maximum path.
Correct. So, but actually, every particular software is a collection of components, right?
Okay.
So component means it's a function, right?
Correct.
So each function efficiency, it makes a matter. That's right. So we don't worry about hardware. As per the course directions and instructions, we worry about only the time of the algorithm, not the hardware. Clear?
Correct, sir. That part I understand, but even if you take from pure software point of view, if you want to understand, for example, the total function, how much time it is taking from the start to end.
Correct.
We take from, say, for example, what you are showing right now, we start with the timing, start from s equal to 0 and return s up to that point. What is the time taken? We will consider that is the time.
Correct.
Similarly, a second person writes the same program. He may have two or three additional instructions or maybe additional loop, and his time will be more. But in the explanation, the asymptotic type of measurement, you said you have to take the maximum, which is only one part of the overall algorithm. It's not
highest term only taken.
Highest term. So
correct.
what is the advantage of taking the highest term? Because that is actually not giving the real timing for me to understand what is the performance efficiency of that algorithm.
See, n is my input size, right?
Right.
So based on the input size, the remaining parts will be changed.
Correct.
But these parts are constant, right?
Correct.
So that's the thing, constants we ignore.
Oh, okay.
Everyone have, that's it.
Okay.
Right?
So for what you're saying is, if I start increasing n to a very high number,
correct,
whatever the constants will be negligible, and only the n will going to decide the real performance of the algorithm.
Yes, very good. So actually, you came to the point. Very excellent point. You have been reminded me. See, there is OPP examination, is it right?
Right, sir.
OPP examination, as I said, 4 problems we are giving. So I think I don't remember, because based on that Professor Madhavan pattern of examination, definitely second question or third question, definitely they will ask you log n complexity.
Okay.
So forget about log n. What is log n? That we'll discuss later. So to prove this, your particular implementation is matching to log n complexity. They try to import the input size of 20K or 30K size.
Okay, understood.
So huge input, they want to dump it.
Okay.
So what happens, that dump, when your particular algorithm is working, it is crossing the ideal limit.
Okay.
Immediately it shows, even in your lead code platform also, right?
Right.
Some test cases are there. They say the time limit is exceeded, right?
Right, sir.
That's the reason, because of this. Yeah. Thank you.
Understood.
It's a good one. Yeah.
I was confused actually why we are doing
that's I got it. Yeah.
Right. Understood.
Good point.
Thank you very much.
So you said this point so that I recollected Madhavan pattern of OPP examination.
Sure. Okay. Thanks.
Yeah, good. So now, so our goal is to reduce the number of instructions when the program is running, not written program, right? What is running at a time when inside a loop or inside iteration, that particular one based on your n size, that we want to reduce it. So that reduction is more important. Other than the constant parts of the program, we can ignore it, because variable declaration, variable initialization, these are all unit of time only, just assigning the value in the memory, just we are accessing. Now, the Madhavan, even in his lecture also, he has given very good example of GCD. The same GCD we want to walk through. Generally, GCD or HCF is same. Greatest common divisor or highest common factor, which is common factor for 2 m and n values. M and n values we are taking. What is the highest common factor we want to get it? So of course you see this one. This could be 8 and 12 they have taken. Both of them can be divisible by same divisor, which is 4. It can be called as HCF or it can be called as GCD. If you are taking 18 and 25, the GCD is considered as a 1, because 1 only can divide both 18 and 25. Of course, they call it as GCD. Both of them, GCD or HCF, is same. Now, general approach of this particular GCD is very simple. See, I strongly recommend, don't by heart this particular code. Please remember this written approach. See, this written approach gives you that entire sense of understanding your code. Don't by heart the code. By hearting the code or remembering the code, it doesn't help you, because implementation of the code is just writing the syntaxes of the programming. That's it. But concept is more important. Now, what I do is we do the GCD, the minimum of that m and n we are extracting. For example, if my m and n I've taken m is some 16, n is some 3, minimum of these two we are extracting. So who is the minimum of these two? 3, right? Is it right?
Yes, sir.
Then compute the common factors list from 1 to minimum of n. So when you are trying to divide this 16 and 3, every time what I do is I try to divide 16 with 1 and 3 with 1. So it is divisible. When it is able to divide, okay. So when it is able to divide, we try to, it is, okay. This common factor, maybe I will preserve it in a list. Maybe I can call it a list, because it's a Python, it is. So 1 is able to divide 16 and 3. Okay, we'll preserve it. Then what I do is 16 we are trying to divide with 2 and 3 we are trying to divide with 2. but it is not able to divide. It is able to divide the 16, but it is not able to divide this. We don't store it. There is no chance. Now, 16 we are trying to divide with 3, and then 3 we are trying to divide with 3. So again, here it is passing, here it is failing, because 3 cannot do that. 16 dividing. So that in this particular factors list, maybe you can say it is a factors, common factors, greatest, highest common factors. In this, only one is there. That one is going to be the GCD. Clear? So,
Sir, just a little question. Why we are making a list, like answer list? We can use a variable also, no, sir?
Correct,
Because
correct. That's what improved versions they are talking about. But right now, as per this theoretical implementation, I'm telling.
Okay. Sorry, sir. Sorry.
Yeah. See, look at here. Whatever they discussed in this particular 3 particular pointers, these things are implemented. That's it. See, there is a CF is taken, empty list, and then here they are repeating a loop from 1 to minimum of m and n plus 1. If it is minimum is 3, 3 plus 1 means 3 only, because it doesn't go for fourth one. Wherever it is able to divide, that we are trying to put it in a list, and we try to return the last element of the list. As some of your classmates said, why you are taking? Yes, correct. So why you are wasting the memory space? No need. What we do is eliminate the list. Simple. We take only a variable, MRCF. So that last updated factor only it's there. That is the last dividing factor I, which is available in MRCF. That MRCF is there. Is it clear?
Yes, sir.
So that here you are wasting space complexity. You are wasting space. Here you are not wasting space. Only one variable you are using. One variable. That's it. So that this memory space need not be used here. The list need not be used. So you can optimize that memory space also. But in this course, we are focusing on time complexity only. We don't concentrate on space complexity.
In the first case, you are just picking the latest element from the list.
Correct.
In the second case, you are every time you are updating.
Correct. We are overwriting that earlier factor. Okay. Yeah. So yeah. Okay. Now the thing is, here the important thing, efficiency they are talking about. So both versions, either you take the first version or second version, time is not improved. The time is proportional to minimum of m and n. If for example, if you could take that, my m is 5006, my n is 5001. So out of this, minimum is 5001. So this particular iteration, whatever this particular iteration, it has to run minimum of m and n. That means 5001 times it has to run it, right? Is it right?
Yes, sir.
So that both versions, either you take space, you can reduce it by eliminating the list, the second version, but time complexity is not efficient way. So let's go for some better way. See, he's talking about a better way. So what this better way is very simple. Subtraction, they did it. So what they did is, they have taken the maximum and minimum of both m and n. That means I'm pretty sure A will get always maximum, B will get always minimum, because based on this particular tuple, see, maximum of m and n, minimum of m and n. So always A get max, B get minimum one. So when that lower B is able to divide higher A, then you return the base case, that's a B value. B is ultimate. So one base case is given. Otherwise, every time they are sending B as a first parameter, subtract that remaining value of this particular B. For example, they can consider, maybe you can talk about that any m and n you can take. So every time what happens, it's going to reduce it. Maybe you can take maximum and minimum. Let us assume that maximum minimum you got it is, I got it is 16, I got it is 4. Maximum minimum, because as per this particular equation. Now the thing is, simply it can be solved that A divided by B, it is done. Remainder we got 0. So highest GCD, sorry, greatest common divisor we got is 4. Within 1 unit of time, right? Is it 1 unit of time?
Yes, sir.
Because it's a best case. What you can say, it's the best input you have given. For example, A I have given is 16, B I have given is 3. Sorry, forget about it. I'm sorry. Yeah, it's a 3. It's a 3. In this case, what happened? It is not satisfied, right? This base case is not satisfied, right? Then what happens? It comes to here, else part. In this else part, what you are doing is, again, you are recalling the same function. 3 we are sending here. Here, A minus B we are sending. That means 16 minus this 3, 13 is sent. Is it right? Hello? Is it right?
Yes, sir.
So every time it is happened. Every time it is happened means next time what happened, 10 will go. Is it right? Hello?
But sir, this process will be very complicated. Na?
Wait. Of course, if it is going continuously, it happens, okay? Up to this particular, A and B is divisible, that's okay. But this process, what happened is, see, there is interesting thing was given, right? So actually,
exactly.
This is a wrong value. Actually, it is not the right value. What happens is, there is an example case you can take. For example, I'm taking M value, sorry, about M and N, because we don't talk about M and N because always max and min. Forget about it.
So you can take 1,100.
Correct.
For example.
Don't take 1,100. 1,100 is immediately divisible because actually this is the wrong values. I don't say these are right values because immediately 1 and 1000 means immediately it is divisible. I can say that 2 and 999. Is it right?
Yeah.
What happens, this one requires every time subtracting 2, definitely it requires 500 times. Is it right?
Yeah, absolutely.
Is it right? Everybody I'm talking about, because first time 997 will come because every time you are subtracting 2 only, then 995. So everywhere this 2 is not able to divide this 995, right? Hello?
Yes.
Yes, sir.
So totally it takes that 500 times to get that complete particular one. If you are taking this 919 is okay. If you are taking the 9,999, then what happens? This recursion tree keep on going, not only 500 times, it's going still depth. Actually, there is a wrong values. Actually, 1 and 1000 is not right because immediately they are divisible this case, right? Is it right? Please try.
Sir, because 1000 divided by 1 is 0. That's why, right?
Any number can be divisible by 1, right?
Yes, sir.
So that's the thing. Don't prefer these. These values are right because I suggest them to change the content. Okay. Yeah. This is still it is failing in some cases. So earlier cases is okay, but whenever this case, still it is not efficient because of the subtraction. So this subtraction example is this. Every time only the value 2 is subtracted. So whenever value 2 is subtracted, it's going to be the, whenever a large difference is there between A and B, the subtraction takes 500 times. 500 subtractions it is doing. 1000 subtractions it's taking. So still it is not efficient. So instead of doing this, still they are going for, there is a mathematical order as defined. This is what? Euclide's formula. This particular Euclide's formula is efficient. Why it is efficient is very simple. Instead of doing many subtractions, so we apply remainder or modulo, remainder. So the remainder is what it will do? Many subtractions. Is it right? Remainder means what? Many subtractions are not done. Hello?
Yes, sir. You're right.
Mathematically it is given. Simply it is what, simply what they did. See.
Sir, could you repeat once again? I couldn't.
See, what we do is, this 999 is there. This 2 is there. we are doing that 500 times of subtractions, right?
Yes.
Yes, sir.
Instead of doing this, what simply they are doing is this triple line, they try to do the mod with this 2. So what happens, this 998, one reminder we got it, right?
Yes, sir.
This reminder is able to divide this and this. So what is the maximum iterations you require? The maximum digits of max of M and N, right? Out of this M and N, what is the maximum number? 999. How many digits are there?
3 digits.
3 digits. So maximum within 3 particular iterations, you get this particular common GCD using this Euclid's formula. So let's see that how they have implemented. You see this one. Simple. See, look at here. Same way, A, they are taking maximum value, always maximum, of course, 999. Same case I'm taking because how the efficiency is done. B, we are taking, let's take 2. So in this case, what happens that it checks whether the 999 is divisible by 2? No. Is it right? It's not divisible, no?
Yes, sir.
So when it is not divisible, it's going here. So next GCD, what it will call, 2 is sent here. The remainder of 999 and this B. So remainder of 999 and B is going to be 1, right? Fine.
Yes, sir.
Now 1 is able to divide this A because A is a bigger value, B is a smaller value. B can divide this A. Oh, got it. So that GCD is going to be the 1 finally. What is this is simple. Instead of doing many subtractions, we do a simple division so the remainder can do the job. Is it clear?
Sir, here only 2 steps are being iterated.
Maximum is number of digits of the maximum number. Maximum. So the Euclid's formula maximum is, see, maximum is proportional to the number of digits. Not mean that exactly 3 times, maybe 2 times or 1 time.
Okay. At the highest, it could go as number of digits, but it could even finish less than that.
Less than that, less than that, proportional to that.
So in this case, instead of doing multiple subtractions, you are basically saying that, okay, these are all subtractions we need to do. You take the final remainder value and do the GCD. Okay.
Correct.
Sir, in the meantime, while you were discussing, I thought something like using the while loop, we can do it more efficiently.
Okay, you want to do with the while loop. So even while loop also, you're supposed to write a condition, right?
Yes.
That while condition is definitely this. Until my A is, see, maybe I'll write the while loop. While my particular A divided by B not equal to 0. If it is equal to 0, it will stop, right?
Yes.
Is it right?
Yes, sir.
Yes, sir.
Inside, what you do, every time we try to update the remainder into A and B, right? A and B. So A is nothing but we are getting the B value, but B is getting B is getting A mod B, right?
Yes.
Fine. For example, you take that whatever 999 you have taken, B is taken, it's a 2, it checks. Is it divisible? No. It's not divisible, right?
Yes, sir.
So when it is not divisible, it enters. So B value assigned into A. Maybe directly assigning for that B, it will overwrite. Maybe you take some temporary variable. You try to do that one. B, you take it as a temporary one. Later,
you can see my solution in the chat box.
Okay. Wait, how much time it takes? Maybe, yeah, just a minute. That will help you. Yes, yeah. So, correct. Yeah, this is okay. This is a simple tuple. B is assigned to A, and then every time it is okay. So this time also definitely it's going to be the highest number of digits of this particular A and B, right?
Yeah.
Simple. No. Actually, why they have given about recursion is to recollect the concept of recursion. That's it. Nothing else. Okay. Yeah.
And sir, the other method will be import library. Import math. GCD called method GCD of A comma B.
No, GCD is not a predefined function. It's a user-defined function. So it's a recursion call. This is recursive function. Clear?
But sir, I think
No, why they have implemented with recursion is to make you to in future we need to write DFS, BFS algorithms in recursion approach, right?
Yes, sir.
That's the reason, again, they have just given a particular initialization for recursion. Clear?
Okay.
Sir,
Hmm.
sir, you have shown us a GCD problem with having 3 versions, like easiest version to kind of complex, optimized version. Sir, the easiest version usually every programmer will gets, like this is the process we can solve the user. How can I get the intuition behind this version 2 and version 3? Like without seeing a answer, I don't think we can click like we can use this method to solve GCD. Like how to get an intuition behind this?
No. Actually, you're talking about programmer's perspective. Like, you are a learner. You feel that this is a comfortable implementation, right? This is a comfortable implementation.
Yes, sir.
This is a comfortable implementation.
Yes,
Maybe
sir.
this could be comfortable or this could be, right?
Okay,
because you have a simple iteration that will help you then. Fine.
Yes, sir.
Fine. So as a programmer perspective, you're right. It is easy to understand, easy to implement. Yes, you are a learner, you can. But I'm running a business. So let's assume that I'm running one particular food delivering system, right?
Yes, sir.
So in my app, so as and when a customer is selected a food item at a particular restaurant, immediately there is a nearby gig employee will pick your parcel and immediately will bring it, right?
Yes, sir.
There is a sorting and searching algorithm will run, right?
Yes, sir.
That sorting and searching algorithm, it has to take a fraction of seconds, right?
Yes, sir.
Then only every particular customer will use your food application, that food delivery app. Otherwise, nobody will choose your food delivery app, right? For example, as and when item is selected immediately, so it is taking 1 hour to pick particular item from the restaurant. Then anyone will visit my mobile app? Definitely nobody visit. So then, see, ultimately, see, you are a learner perspective, you're right. But whenever a particular employee I'm recruiting to my business, I always choose a person who will implement optimized algorithm, right?
So like these optimized algorithm, we need to kind of memorize, like this
Not
is the approach.
Not
like
memorize,
approach.
practice. Okay. It's a practice, right? First time you will understand the concept by reading and memorizing the concept is okay. But after maybe 3 days, 4 days, you need to remember lifelong means what? Simply you need to practice a lot, right? Okay. So because whatever you said is, as a learner, you try this attempt, okay, this is good. But as I said, to run this particular GCD problem, if I'll give it for OPP examination, Mr. X has implemented a GCD, this approach. This Y is there, he has implemented efficient approach. I will send 10K inputs for this. I will send 10K inputs for this. To process this 10K, it was taken maybe time of 2 microseconds. To process this 10K, maybe it requires that 5 seconds. So this evaluation is, this problem is wrong, this problem is right. The solution is right. Clear?
Got it, sir.
Okay. There is ideally, actually, Madhavan is given very good implementation. The Professor Madhavan is given very good timer implementation also. I'll show you that in this document over there. I'll show you how really the time is detected, right? Okay. Because that code he has implemented, he has given in the part of this GitHub documentation. That could be the last part. That will give you how really the timer is running background to check your efficiency of your code. Up to this is clear, everybody?
Sir, I have computed the GCD using import math function. Like import math and GCD equal to math GCD. Using the GCD, I can easily compute the.
You can compute it. You can have, but built-in functions also some complexity is there. But we need to just Google it. even the list append function requires some complexity, right? Hello?
Yes, sir.
Yes,
Because
obviously.
the square root function, all these are some built-in complexities is there. That may be considered or not, that will be, that is based on that problem question they have given. Okay, built-in function also, it is going to the function, compute it, there is a power function is there. It has to go to the power library and then compute it and math library and coming back. It requires some time. That is also considered. But how much is just, you can Google it, maybe how much GCD built-in function taking time complexity, Python library. Yeah. I think, is it okay now? It's clear?
Yes, sir.
Yes.
Now,
So the
this is...
built-in will always be faster, right?
No, I cannot say that one because maybe some people ideally they'll come up with a better approach instead of using built-in one mathematically. There's the shortest way to compute. Why to go for built-in function? They might have. Clear? Yeah, there are some maybe approaches. Even a built-in GCD also, maybe it is using that same Euclide's algorithm. Maybe it's true. Then it is built-in function also similar complexity.
Yes,
Yeah.
sir. And also it's time, how much time it's take to run the program also. That's also differ.
Yeah. Now, this
Sir,
another...
like you just said that some people might be able to write other alternative approaches which might be better than the built-in functions. But then, sir, we also need to consider the language differential, right?
Yeah, correct. Out of that all programming languages, C and C++ is efficient, right?
Exactly. And sir, the Python built-in functions are C and C++.
Correct. But some lead code problems and some hacker rank problems are there. They will run efficient way in C and C++. They'll take some time. That's true. Because C and C++ is more mission oriented. They can directly access the pointers and memory addresses. They are faster, right? But okay, that is not considered by the company. Company never targets about what language you are using. They target about what approach you are following, right?
Okay, sir. Thank you.
Yeah. This is pretty simple. Prime number, everybody knows what is prime number?
Which can be divisible by
one
1
and
and this number.
1 and itself.
One or that number.
Correct.
1 or the number.
1 and that number. Between that 1 and that number, no other factors, no other division facility is there. So here, again, 3 different approaches they talk about. There is a factors list they have taken. See, look at here. There is a factors list. So why they are repeating up to n plus 1 is they want to list out all the factors from 1 to n plus 1. They want to check it whether it is divisible. When it is divisible, we are trying to append into that a particular list, and that list we are returning. If that list contains only 1 and that number, we return true. This is what the return true, because equality they are checking. This function is a factors it is returning. Whatever the factors is returning, if that factors contains 1 and n, it returns true. The prime returns true, otherwise it false. So these 2 functions they are using by this one. This function is called by prime function. Prime function is called by this function. So you can see this one. So m, up to the m prime numbers we want, it means every time we take the first number, whether it is a prime or not. If it is prime, we are appending. If it is not prime, we are not appending. Now the complete PL, it contains that list of prime numbers up to the m. If m value you have taken, if m value we have taken is 10, we get a list of prime numbers. 1, 2, 3, 4 is not a prime, 5 is a prime, 6 is not a prime, 7 is a prime, 8 is not a prime, 9 is not a prime, 10 is not a prime. So that you get the list up to this, right? Right?
Yes, sir.
So these 3 functions will do this job. Now, what is the time, number of units it is, if you consider all these are? If, for example, 10 number of up to the m prime numbers I wanted, what is the time it requires? What is the time?
5 units.
20 units.
No. Consider in terms of input size is M, right?
M,
Okay,
sir.
M square.
M or M square?
I think
M
it's
or
M.
N square?
M.
Sure?
I
See,
think
look
M
at
plus
here.
N square.
See. First time, when you are giving this 10 as input, this particular I is taken with 1. This particular prime function will call the factors 1 to 1. One factor is picked so that it's okay. So first time, one factor we are finding, this happens one time. Second time, when you are coming with M value is 2, that means I you are sending is 2. The factors it is generated is
1 and 2.
1 and 2.
So it's
right?
M square.
That's what. M square, or you can say N square.
N square.
Every time this particular prime is calling another iteration here, right? Is it right?
Right, sir. It's a loop within a loop, right?
Correct. This particular loop is calling this function. This function is calling returning factors. The factors is calling this N time. So,
Sir, because this is inherited with another function, that's why it is N square, right?
Correct.
If it is not inherited with any prime function, then it should be N only, right?
Correct.
Okay, yeah, done.
So this it is taking N square or M square. Now, instead of doing this, there is a counting of primes. What they did is, as everybody said, prime means it is divisible by 1 and itself. 1 and itself. So other than 1 and itself, see, directly check if n has a factor between 2 to n minus 1, then what happens? It is definitely not a prime, right? Is it right? If it has anything, it is definitely it is not a prime. False. 1 and itself, every number is divisible. Other than 1 and itself, n minus 1 and 2, if anything in between, definitely it's not a prime. So that they went for this approach, other approach. This is the other approach. What the other approach they did is, this one is 2 to n, they are repeating, they are not included 1, they are not included n. So n means n minus 1. Every time what they did is, whether n is divisible by, if it is divisible, actually they can do break also here. Actually, they forgot to do the break.
We can also use opposite condition.
They can stop it, no break.
We can also use opposite condition, na sir. We can use n mod I not equals to 0.
That's okay. But thing is here, this could be no. What do you want to do opposite condition?
N mod I not equals to 0.
Okay, not equal to 0 means what do you do?
Not
when you see, if you take a 15 you want to check it, you should not check with 1 and 15, you should check with 2 to 14, right?
Yes, sir.
So that one we are doing. So instead of it, you can do a break. No, after this false, I can put a break, right? Is it
yes,
right?
sir. Yes, sir.
If it is not a prime, in between 2 to 14, somewhere it is divisible. If somewhere it is divisible means you get a false. False means it's not a prime. Not a prime. For example, my input is 15. You need to check it from 2 to 14 times, right?
Yes, sir.
So the 2 to 14 times you need to check it. So never this break is executed. This result is true. Definitely you get it is a prime. Is it right?
Yes, sir.
15 is a prime, no, right? Okay. Hello?
Yes, sir.
If it is prime, it is going 2 to 14 times. If it is not a prime, between it is stopping. Is it okay? If,
Yes,
for example, my input is 16, it will be stopped at 2 itself, right?
Yes, sir.
Because by the 2 itself, it is divisible. We got a false, immediately break, immediately result, we got it. Now,
sir, sorry for interrupting over here. If break is not mentioned, but the result will set to false, and at the end it will obviously return false only, right? If it is
correct.
But we are just wasting some memory.
Correct. No, wasting it's not memory, but here the time is more important.
Time is.
Yeah, sorry. Time is wasted.
Here,
okay.
if you give a prime number, definitely here it is taking n complexity, right? Is it right?
Yes, sir. Yes, sir.
If it is not a prime, 1 unit of time it is running, right? Because first time only it is 16 is divisible by 2. Is it right?
Yes, sir.
But if it is a prime, you need to go up to the n. So instead of going again up to the n, we go n by 2 times. Half of the times is okay now because division operation, right? Is it right? Why to go up to that n minus 1? You can go up to the n by 2 times, right?
Yes, sir.
Is it right?
Yes, sir.
To check this 15 is prime or not, I need not go up to the 14. I can go up to that 7. Is it right?
Yes, sir.
So that is the next level. See, that is the next level. See, this is directly check factors between 2 to up to the half of the n. So now still we got better time complexity, right? Is it right?
Yes, sir. Yes, sir.
Still somebody what they say is still n by 2 why to do? Can't you try square root of n? Up to the 2 to square root of n?
Sir, a small doubt. Why are you taking n by 2, sir? Like, a small logic could you give for
Definitely.
selecting?
So definitely. So if it is 16, is it right? Okay.
Yes, sir.
So this is not a prime. Clear?
Yes, sir.
To check this prime, whether it is a prime or not, I can check it. I can check it up to 2 to 8 is enough, right? Is it right? Why to go up to the 16?
Yes, sir.
Okay.
Yes,
Why we are not going up to 16 is off of the 16 we can divide 8 2s are we can divide 16, right?
Yes, sir. Okay.
So
For even numbers, 2 is a factor.
Correct. Fine. Now 19 we have taken it, right? I can take integer off only. Don't take the real number. So I can go up to the 2 to 8 only to check this whether it is 19 is prime or not. Is it right?
Yes,
Okay.
sir.
Sir, small. So because the minimum number of factors would at least lie in 2 to 8. So if they are not there in there, it should not be even
Correct.
post 8. It won't
See,
even occur.
19 ones are 19 we get it, right?
Yes, sir.
So 1 is definitely can do that one. 1 you can divide, 19 we can divide it. So 2 with 2 we tried 8. So what is the half of it, right? That half is that
Yes,
equal
sir.
partition we can do that one because
Oh.
so we can easily divide with 2. That makes sense, right? 2 8s are 19. See 16 we got it. 2 9s are 18. Is it right?
Yes, sir. Yes, sir.
So that's ideal factor, ideal division possibility. Still, somebody says why to go up to the n by 2 times? Don't worry about double slash, it's integer division. So here, go up to the square root only. So for example, to check the 16 whether it is prime number or not, I need not go up to the half of the 16. I can go square root of 16. That means 2 to 4 only. What is square root of 16? 4, right?
Yes, sir.
So this is still very optimized. Very optimized. So of course here also it is, integer only. Don't consider it is a real one because maybe you get square root value in real number. We consider it is integer only. For example, integer, I'm saying about math one, no? Integer math function it is math dot square root of 16. Yeah, it's 16. I'm sorry, maybe from import math.
You have not imported, sir.
Yes, correct. Import math, yeah. So forth. So similar way, maybe if I want to get it some square root of math dot square root of some 19, you get real number, but we try to take the up to the integer part only. So that's the implementation they want to do it. The next part, see, look at here. This is okay, half of it. Of course, here also they can use a break. So here, yes, here, see, They want to check, sorry, of course, actually here they have used a break. Actually, I thought it is earlier, but anyway, solution they have given a break. Yeah, here you see this one, up to the square root only. It's a sufficient to check the factors up to the square root of n. So for that, it's pretty simple. The complexity, it goes up to the square root of n only. You need not go up to the n. You need not go up to the n minus 1. You need not go up to the n by 2. You need to traverse up to that square root of n only. So still it is better optimized. So that if 16, when it is divisible by 4, simply it is not a prime. Simply it is not a prime. 25, it is divisible by 5, it is not a prime. Simply it is not a prime. So 25 is there. It is not divisible by 2. It is not divisible by 3. It is not divisible by 4, but it is divisible by 5. Because it's a square root of this particular 5. 5 is enough. It can close the session. Simply, the time complexity, it goes up to the square root of your input size of n. So out of all this, this is efficient one, right?
What if n is 1 here?
Correct. So if it is 1, there is a edge case. Maybe you can take edge case. You can write one base case here. If my input is
1 is not a prime number, right, sir?
Correct. It's not a prime number. That's what the reason. If my input, maybe that n value is 1, then you can say 1 or below. You can say, sorry, your n is not in the range of prime numbers.
Okay, got it.
That's
Because
edge
the
case.
current implementation, we will get prime as true if we give n as 1.
No. Is it will true?
Yeah. Because I is 2, right? And result is initialized as true. And 2 is not less than square root of 1.
Correct.
So while loop itself, it will not enter and it will simply return true.
Yeah, correct. But 1 is not a prime number, right?
Yeah.
So that's the reason. So maybe you can check a base case here. Edge case you can write, not base case, edge case.
Okay.
So that edge case, it will detect that input error maybe. Yeah. That's called, sanitization of data, right? Okay.
Sir, so this function is running total root n times. No?
Correct, root n times, correct.
So sir, overall program is running n into root n, no, sir?
No. So if, no, it's not any. It's only detecting whether the current number is. For example, whether my 10 is prime or not, it's checking, right? For example, you want prime numbers up to 10, right? At this time, what happens that every number you are checking, so in that range of prime numbers you are picking out. So the prime numbers you are picking out means 2 we are getting, 3 we are getting, 4 we don't get it, 5 you get it, 7 we get it, right? This is root n times. This every time you are calling. So at that time, what happens that? Total complexity, n into
root n.
Correct. N into root n. Clear?
Okay. Now it's clear.
Correct. So because current function is considered as a root n, if n times you are calling for n number of prime numbers, so that n into root n. Yeah. But it is much better than n square, right? Correct. Yeah. Up to this is clear? Yeah. Actually, this exception part is not very much important, but anyway, just syntactically they want to show you. See, how to handle the exceptions in Python is very simple. There is a try block is there, exception block is there. See here, this is one example. Actually, we don't use much in the PDSA course this exception, but anyway, yeah. Every time we try a code block, whether it is able to execute successfully or not, if any runtime error is there, there are runtime errors, different types are there. There is a named error is there, index error is there, name error and key error is there. Name error, key error means maybe the dictionary key you are calling is not exist or invalid key. So these are named errors, like, named exceptions you are handling. If except is given, it can handle all types of exceptions. Either divide by 0 exception, array index out of bounds, all these are. And none of the exception is satisfied. That means no other errors are executed. So it will execute whenever try works without any errors. That means try is executed, no exceptions are executed, that means no errors are thrown, then else part is executed as a default. That will be done it. Of course, we don't worry about exceptions and we don't implement exceptions kind of algorithms in this PDSA course. You can ignore, and I don't find any relevant question in quiz or end term or anything there in this particular on exceptions. You can ignore it. Now,
sir, a small doubt over here. Why are you using else part, sir?
Correct. So if
try is enough, right?
No, see, look at here. There is a special case, like, there is a file is open here. File opened, right? The file opened. While reading, you might got some exception, right? Clear?
Yes, sir.
If exception is happened, that exception you are returning. So, actually, this else part is, if try is executed, then only else part is executed, right?
Yes, sir.
So then exception is executed. If exception is executed, else part doesn't execute. Actually, I'm not very sure about it. Actually, else part I consider as a default part.
Yes, sir. If there are no mistakes, then else would be executed.
No. Actually, if else has to be executed, whether exception is thrown or not, it has to be executed. That's what my thing.
Actually, I remember we used finally in the Python course, like for this purpose.
Maybe I think so. Yeah. I'm not sure about it. Yeah, you can just refer it. Maybe Python documentation would help you a lot. Is there any exceptions part? Fine. You check it. Maybe some document.
Okay, sir. No problem. I'll go through it.
Okay. Yeah. So now, classes and objects. So in this PDSA course, we are implementing some part of object-oriented part only for some particular concepts like linked list, stacks, and queues. So in this part only we use it classes and objects. So you just quickly recollect it. Class means it's a collection of data elements and methods or functions are there, and it's a user-defined data type. We are trying to instance the object using the class, and class contains instructors. Constructors are there. Some operators overloading also there. Like you want to convert the class object into string. You want to do some addition operation on the class object.
Sir, are you sharing your screen?
Is it not visible?
Like classes and object part you are sharing?
Yeah, it's there in the same documentation.
Okay.
Wait. Here it's a documentation.
Okay.
No. Before I'm scrolling, just I want to talk about that.
Okay. Sorry.
Yeah, this is okay. This is whatever I said. It is, it's an abstract data type, user-defined data type you are creating. In PDSA course, we are using for stacks and queues. The particular, I think, third week is the third week exclusively we are implementing stacks and queues and linked lists. There we are using class and objects. So in this classes, we try to define functions as a public things and data members as a private elements or private member functions. We write it. So here, once class is available, we try to create the object of it. So instance of it. So that is called instance of the class. If it is stack class is there, we create a stack object. If linked list class is there, we create a linked list object. Here there is an example. See, it is very easy example. You can see a point contains x and y coordinates. A and B is taken as a parameter. They are assigned into self.x and self.y. Self is used, it means that's a data member that is resided inside of your class. Now translate, they are using delta x and delta y.
One thing, self.x plus equal to delta x. What does it going to do here?
What is it?
Self.x plus equal to delta x. Each time you are getting self.x, you are implementing the count with delta x. But
this part only, right? You are talking about?
No, the next part, translate.
Next part is, that's what I'm talking. This part is clear. Now I'm not started with the translate. Translate is, what it is doing is adding the existing x coordinate with recent delta x. This is addition operation, right? Clear?
Means, sir, can you take an example? And
correct. So there is a point we are creating. There is a point we are creating. Maybe point if you created with x and y coordinate of 3 and 7, right? So this P, I want to add something like P dot translate. I'm sending a new values of 1 and 3. So this one already available x and y is there. This x is added with 3 plus 1. So that this new value of x will become 4, right? Is it right? Is it right?
Yes, sir. Yes, sir.
So same thing is happened for y and 7. So that 7 and 3, it's going to be the new y values. Simply adding of new parameters to existing values. Whatever the delta x and delta y you have taken, those are added. That's it, nothing else here. This is addition operation. Now, calculating the distance. There is Euclidean formula they are doing, square root function. So x square plus y square, that square root of these two we are taking. That's going to be a distance you are calculating between points. So there is x and x square, so no, that Euclidean distance you are calculating. So now you see this, here it is. These two things are overloaded functions. Overloaded. Because if you want to print a point, whatever point object is created, it will print the particular x value comma y value. So 3 and 7 in this pattern it will print. Similar way, adding we want to do 2 points you want to add it. For example, first point P1 you created 3 and 7. Second point P2 you created 6 and 2. These two you want to add it. Simply I can do that P1 plus P2. That is done by this add operation. So this plus operation will call this add, because how do you know this is overloaded functions? Is overloaded functions are prefixed and suffixed with underscore. That's simply, you know, it's a predefined overloaded function. It can do string operation, it can do add operation. Similar way, subtraction you can do, multiplication you can do. So that things you can do. Up to this part is class. This is end of the class, right? Sorry, this part is class. I'm sorry. Yeah. Up to this, the class is ended, right? Is it right? Is it right?
yes, sir.
Now, the main program is started. See here, 2 objects are created. First object is P, second object is Q. 2 point objects are created. 2 instances. So they are printing P. Just whatever the values of 3 and 4, they are printed. That's a point P is printed. So how this is printing? Because of this str function. How these 2 points are added? Because of this add operation. The add operation will create that addition of first point and second point. First point is x. Second point is P dot x. First point is y, that is self dot y. Because P and Q you are taking means P is considered as a self, Q is considered as some second argument called P. So that is called, you know, current object. These 2 addition we are getting a print. So addition means maybe 8 and then 12 we get it. That simply we get the output. So yeah, that's pretty clear. That's what.
So sir, this self variable will assign a value of P variable, na sir?
First parameter.
First parameter.
Correct.
Okay.
The addition operation contains 2 parameters because it's a binary operation. It contains an operands and operator between, right?
Okay.
So that left operand is considered as a self.
Okay.
Yeah.
Okay. Got it.
Sir, this print P plus Q here, plus sign is mapped automatically by the Python to add.
This add operation. Okay. This add operation, because it's operator overloading.
That's
right?
the internal. Okay.
Correct. So
sir, self is the name of a variable, right? We can use anything over there. Right?
Name of the current object. Correct. So if you are setting P and Q as addition operation, P is considered as a self. So that's the thing. Self dot x means this 3 is referred. Self dot y means 4 is referred, right?
Okay. Yes, sir.
Okay, got it. So if you are doing Q plus P, Q is considered as a self because first operand is considered as a self because it's a binary one. Yeah.
Understood, sir. Yeah.
So, sir, it will give 3 plus put such kind of things.
3 plus? No. If it is
3 plus
integers, that's a built-in operation, right? These are user-defined objects. These are objects. These are not data types, right?
So, sir, self.x plus p.x, it will give us, I think, 3 plus 5 will be
Here you
added.
want right. Here you want right.
Mm-hmm.
No. Here you cannot write because it is taking one parameter only, right? The first parameter is considered as self, right? See, plus operator is taking two parameters, P and Q, right? This left side one is taken by self, right? Right side one is taken by P, right? Actually, they're supposed to use it some X here, some K here to make it avoiding this confusion, right? Is it clear? Add operation is taking two particular arguments, two operands. Left operand, right operand. Left operand goes to self.
So basically, this add operator is different from integer adding, like
Correct.
two number addition.
Integer adding is a predefined operation. We
Yes,
do not
sir.
do any
This is an
overloading.
object operation,
Any
like how.
overloading. Here objects we are doing addition, right?
Yes, sir. Okay, how objects will be added.
Correct. Okay. Shall I proceed for the next?
Yes, sir. Yes.
Now earlier I said actually the timer, everybody is worrying about how really timer is evaluated for our algorithms. This will give the answer. Maybe seek backend is using to check the time complexities of your efficiency of your algorithm in this way. They have already predefined, timer error class they have. They are using existing library of Python. They created one timer class. This timer class contains start time is there, elapsed time is there, which are two data members. Initially, these are none. They don't have any values. As and when you call this function start, what the start will do is, it will take, if the self.start time is not none, if it is not none, that means it contains some value, timer is already running. It say that already I started counting of time, don't start me again. That's what this error it will rise. So for example, if it contains none means not yet started. Not yet started means what it is calling is self.start time is, it is getting that current performance counter of the current clock time. What happens, this time function, time library earlier we have imported. This is a Python library. This library contains performance counter. This performance counter will give current time in milliseconds or microseconds. I don't still remember, but some particular current time, maybe current time in milliseconds, maybe let's assume that 5001. Remember, it's a 5001. Just you example you take it as per current time of this 10 hours 5 minutes, it's going to be 5000 once again. Let's say take some rough number that is available in start time. Start time is recorded, it is starting. Now stop time is there. There is another function, stop time. If start time is none, if start is not there, how can I stop it? So if start time is none, you get error. Sorry, this timer is not running. How can you stop it? First you start it, then you stop it. Okay. So if this condition is satisfied means timer is already started. That means this condition is not satisfied. Then it goes to here. In this, what happens? It takes another time performer. So this time is, earlier it is 10 hours 6 minutes. This timer count is there. At the stop, what it will do? There is a new time performer it will take. Maybe it is 5009. Because we stopped the time at 10 hours 7 seconds, 7 minutes, right? Is it right? Is it right?
Yes, sir.
The difference it is taken. What is the start time? 5001. What is this end time? it is 5009. What is elapsed time? 4. Is it right? Sorry. It's 8. I'm sorry.
8, sir. Yes.
8. So 8 is recorded. This elapsed time is recorded. It will hold. So let's use that elapsed time for some purpose. We'll see. So elapsed time is, if elapsed time is none, elapsed time is not at run, you start to record it. If it's already available, it will return. So elapsed time it will return is 8. Up to this is clear? Up to this is clear?
Yes, sir.
Yes, sir.
If timer is not started, it will suggest you to start. If timer is started, you can do stop. If timer is not started, it will give error. So the timer is not started, how can you stop it? If timer is started, before stopping, it will take current time, elapsed time, and earlier time, the difference it will pick up and it will put it as elapsed time. Now the thing is, this is okay because it's an overloaded one where it returns elapsed time is how much. That's, we don't worry about it. Now, interesting recursion they are using. See, earlier GCD function is there, no? I think just you recollect it, right? Is it there? Hello? Yeah. Okay.
Yes, sir.
See, there is a sys they are imported. In the system, we are making a recursion limit of, I think it is 1 lakh times. Maximum 1 lakh times only recursion can be called. Is it okay? They said it is 1 lakh. They are trying to call 99,999 with GCD value of A is 2, B is the highest value. Of course, A will become high and this one. So what happens, you know, if this recursion limit is crossed, so what we check it is, we take a start time. Okay, we take a start time. Then we try to take the GCD. Oh, actually, why they have called this one, I don't understand. Okay, you forget about it. Maybe, yeah. GCD, they have taken a bigger numbers, right? Very, very bigger numbers, right?
Yes, sir.
Before start of this particular GCD, there is a start time is recorded. As earlier I said, it is something like it is 5001 is recorded. This GCD is executed maybe some time, maybe 5 seconds or 6 seconds or 7 seconds. After this is executed, we are trying to call stop. Maybe stop is executed 5009. Once done, the print T means you get elapsed time of 8. Okay, is it right? Is it right?
Yeah, sir. Difference is 8.
Correct. Now this is your GCD function. Your GCD means Mr. Ram has been coded, right? Is it right? This code is given by Ram. So I'm calling in my backend server, the Seek server. I try to call this one. So I got that elapsed time is 8. Okay, right? Is it right? But backend server has some ideal algorithm. That ideal algorithm, it is GCD calling an ending time. It requires only 5 seconds maximum 5. For this, the range of input is this. So your time is taking 8. This ideal time is this. This 5 is less than, this 5 is less than this 8. Of course, you are greater than this one. Immediately you say that time limit exceeded error. Even your second week experiments are there. There is a login experiments are there in GRPS. There is a time limit exceeded error you are getting because of this one. If your algorithm also running less than or equal to 5, then you don't get this error. You get the output. Because maybe backend they are using this timer one. Where is that? This timer. T dot start and T dot stop to evaluate how much time your function is taking. That's what your algorithm, it contains some prefixed code is there. That prefixed code is not visible. The prefixed code will check it whether your function is taking how much time is this. So I think you understood how the efficiency is more important for your implementations. Is it clear?
Yes, sir.
Yeah.
So in this case, how did you get the fixed 8 elapsed time, sir? Because
no, that's example I've taken. For
example. Okay.
This is I started before calling up GCD. I took one benchmark.
Sure. Okay.
Yeah.
Thanks.
So yeah. See why the efficiency, even Professor Madhavan has been talking about Aadhaar card. See, there is a list of SIM cards, maybe one Airtel service or some kind of Geo service. They have some list of SIM cards are there. So maybe multiple SIMs are registered with one Aadhaar card. So what I want to do is, there is a SIM card is there, which has been registered with some Aadhaar card number 1, Aadhaar card number 1, I can say some 12-digit number. I want to find his complete details through Aadhaar card number. Find his detail. So if you consider all of the population of this India, there are 140 crores of people are there. Assume that everybody have Aadhaar card. So to search this particular Aadhaar card details, you need to traverse all these 140 crores of Aadhaar cards to find this SIM card is registered, this Aadhaar person, and what's his address, what's his name, all these details. So maybe it requires 2 or 3 days to search if you do one kind of a sequential way. Is there a better approach? Yes, he suggested to have a sorted and searching policy. If you applied it, you can find out this particular details within fraction of time without taking 2 or 3 days for searching facility. Similar way, searching a big database, because nowadays the data is very used. Even the data is getting a pipeline of your social media, even your GPS service, because every day you are traveling all the GPS, and Google is trying to investigate which longitude and latitude you are visiting. All these they are tracking it. So huge data you are getting. All this huge data they are putting into a big data database or big bucket, and searching the particular, by the time this particular user in which location. So that has to be searched in a fraction of time, right?
Sir, so in the search engine algorithm of Google, they also use that kind of methods.
Correct. They use the efficient algorithm there, right? Clear? The fastest way they want to search it, right? Is it right?
So sir,
yes, sir.
We are getting too much time because we are using Python language, or it's
no, language making matter is that very least priority, because language will fail only some cases, but your algorithm is to be efficient one, right? Is it right? Language will fail only some certain cases. That's very few cases. I can say comparatively efficient languages means C and C++ is efficient in terms of time complexity, because they have a direct mission interaction, and interpreter and compiler is very fast. Python compiler is slower, but Python have huge library support, right?
Yeah,
so every language have their own advantage, but that we forget about it. Whether your algorithm is, your approach of solving is efficient or not, right? Okay.
But sir, different languages used for different kind of work. Like for gaming, we can use she has, or
Correct.
for development we use JavaScript type.
Correct. But standard procedure of algorithms is same, right? See,
yes,
log and complexity algorithms are standard algorithms for any language. Either you write a gaming one or this one, right?
Kind of core of the program.
Correct. Core. Yeah. So similar way, there is Madhavan has given another fantastic example where it is a gaming one, where it is a screen is there. You have that objects are pointed at different spots of the screen. So in this, there is you are playing. Maybe you're playing in this particular part. There are different red color dots indicates that there are different enemies. So I want to investigate what is the nearest enemy. Like I want to find out the distance of it. So similar way, whatever this particular this red colors are there, all these may not be that enemies. Maybe some of them may be a life cover of my game. I can touch them so that I can improve my lifespan, I can improve my life. So I want to investigate. So in this case, so I want to use it. There is searching of that which point is nearer. Again, the fastest way to search, again, if you are using a linear kind of searching the nearest point, it takes that at least 2-3 seconds to take the decision. So 2-3 seconds picking up the shortest distance is very important in the gaming, because gaming requires as fast as, because the graphics cards requires that the gaming implementation, what you did is the efficient algorithm you need to identify. So then only everyone likes to play your game, whatever you develop background algorithm. So for that also, your efficiency makes a matter. So you supposed to write your gaming algorithm in efficient way, whatever searching and picking of the particular one. So navigating to the point and then picking of it. So all these things has to be done in the background process of efficient way. So efficiency makes that end user is impressive. So whenever end user is impressive, he tries to use your software product. Otherwise, he will throw you out your software product. He will choose some other product. That's what today somebody will choose Uber. Some other outstation they went, they'll go for Ola, because they maybe the Ola is working better way in that location. Hope you understand, right? Clear?
Yes, sir.
Yes, sir.
Because of the efficiency of the particular one, because of this particular data set they have, that data set searching, sorting, picking of the data, all these can be done in an optimized way. Yeah, this is pretty much, but second week is totally, they talk about that different levels of time complexities, how to make them improve. All these are relations, you will understand that log, unit of time, O of n, n log n square, all these relations you will know in the second week. Mathematically, how you are linking this particular code is having this efficiency, you can link it to the second week. So I think it is clear. Yeah, we covered a lot for today.
Excuse me, sir.
Mm.
So I have a doubt. Like in recursive function, how do we find out how many times the function will, like
Correct.
recursion will happen?
Correct. So what we do is we try to declare a global variable. For example, you take a factorial recursion. There is a factor of 5. Factor of 5 will call that 4. 4 will call 3. 3 will call 2. 2 will call 1. 1 will call 0. Of course, 0 or 1 is okay, 1. So here what you do is, this is your def function. It is a recursive function. You try to take a global variable, some counter, right? So inside of your base case, the base case generally what you write is, if your n is 0 or 1, maybe then we return 1, right? Is it right?
Yes.
Else there is a recursion call, we do it. In the recursion call, you do that c equal to c plus 1, right?
Okay.
So that after end of this function, you can print this particular c value. C should be a global. If you make it as a global, you can easily detect how many times this particular one recursive function is executed, right?
Okay. So like in GPAs, there are some query questions. So like if
Correct.
those are given with big numbers, then
not big numbers actually, not big numbers. So generally what they ask you is, they try to add the recursive relation. Recursive relation is okay, that's different. GRPA you are talking about means Friday session exclusively the coding sessions are there, right? You are talking about GRPS, no, right?
yes, in GPAs, grading
That's what
assignment,
GRP
graded.
or GPAC, graded programming assignment. In that, they are giving big number input. The recursive complexity, it is how it is calculated. You have a Friday sessions, exclusively we have some problems. We will investigate whether it is taking how many times of comparison when you are using recursion. Okay.
Okay.
Yeah, we have Friday sessions, exclusive Friday session. We have a fantastic problems are there. Some Friday sessions have 4 problems, some of them 3, some of them 5 also. In that problems, they are almost equal to your GPA, and sometimes harder problems than GPA also there. Okay.
Yes. Thanks.
Sir, is the class completed, sir?
Yeah, it's done. It's done.
Okay, thank you, sir.
Hello, sir. I have a question.
Thank
you. Tell Suman, tell
that you have said that we have class in Tuesday, but In my calendar, there is no class.
No. Tuesday TA sessions will be scheduled very soon. Right now, only schedule is there Wednesday and Friday. Possibly they might schedule in the next week. I think so. I'm not sure, but it's okay.
Okay, sir. I have seen that only class has
Correct.
Wednesday and Friday. So
Correct. This week is Wednesday and Friday.
Oh, they will schedule as in calendar.
TA sessions will be scheduled very soon.
Okay.
Yeah. So I think I've done. So I think it's pretty much that everyone got clarified. Any clarifications? So once again, I'm reminding you the PDSA course is not at all a tough course. If you are sequentially follow, even you miss a lecture, I strongly recommend you please go through the earlier session. At least you should go through the weekly coding sessions and summary sessions. That would help you a lot. And along with it, a practice. As and when you get the time, please kindly practice by your own. Okay. Yeah. Okay. So thank you very much. Have a nice day.
Thank you, sir.
Thank
Bye.
you, sir.
Thank you, sir.